Hello everyone, welcome back to High School Mathematics channel. Today we are going to learn class 9, chapter 1 number system, exercise 1.3, fifth sum onwards. See now question number 5. What can be the maximum number of digits be in the repeating block of digits in decimal expansion of 1 by 17? Perform the division to check your answer. Now we have to divide the number 1 by using the number 17. 1 is less than 17. So we shall add 0 point in the quotient. Now the number is 10. 10 is less than 17. So we shall add one more 0 in the quotient and add a 0 here. Now the number is 100. Here we have written 17 table. So 17 5s are 85. So let us take 5 times 85. 100 minus 85, remainder is 15. 15 is less than 17. Since decimal point is present, we shall add a 0 here. Now the number is 150. 17 table 8 times is 136. So we shall write 8 in the quotient and write on here 136. 150 minus 136, we get remainder 14. 14 is less than 17, so we shall add a 0 here as decimal is present in the quotient. Now the number is 140. Again 17 table 8 times is 136. 140 minus 136, remainder is 4. 4 is less than 17. Decimal is present. So we shall add a 0 here. Now the number is 40. 17 table 2 times is 34. So 40 minus 34, you will get a remainder 6. 6 is less than 17. Decimal is present. We are going to add a 0 here. Now the number is 60. 17 table 3 times is 51. 60 minus 51, remainder is 9. 9 is less than 17. Add a 0. Now the number is 90. 17 5s are 85. So keep 5 in the quotient and write on 85. 90 minus 85, you will get a remainder 5. 5 is less than 17. Add a 0. Now the number is 50. 17 table 2 times is 34. 50 minus 34, remainder is 16. 16 is less than 17. Add a 0 here. Now the number is 160. 17 table 9 times is 153. 160 minus 153, remainder is 7. 7 is less than 17. Add a 0. Now the number is 70. 17 4s are 68. So 70 minus 68, you will get a remainder 2. 2 is less than 17. Add a 0. 17 1s are 17. 20 minus 17, remainder is 3. 3 is less than 17. Add a 0. Now the number is 30. Again 17 ones are 17. 30 minus 17, we get a remainder 13. 13 is less than 17. Add a 0 here. Now the number is 130. 17 sevens are 119. When we do subtraction, we get here 11 remainder. 11 is less than 17. We shall add a 0. Now the number is 110. 17 6 are 102. After doing subtraction, we get remainder 8. 8 is less than 17. Add a 0. Now the number is 80. 17 4s are 68. See now 80 minus 68, remainder is 12. 12 is less than 17. Add a 0. Now the number is 120. 17 sevens are 119. 120 minus 119, remainder is 1. So we shall stop division here. Why? Because in the question also 1 by 17. So first digit is 1 only. Again we got same number 1 here. So this number is going to repeat again. So we are going to stop the division here. Therefore 1 by 17 answer The decimal expansion is having decimal after 16 digits. Therefore, there are 16 digits in the repeating block of the decimal expansion of 1 by 17. So, the final answer is 0.058823529411767. We have to mention here bar. Why? Because all these values are going to repeat again. See now question number 6. Look at several examples of rational numbers in the form p by q where q is not equals to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? Now let us see the solution. See the solution. We shall look at some examples of rational numbers in the form of p by q where q is not equals to 0, where decimal representations are terminating. Here we have taken 4 examples. 2 by 5. So we are going to divide the number 2 by the number 5. 2 is less than 5. So we place in the quotient 0 point and add a 0. Now the number is 20. 5 table 4 times is 20. So 20 minus 20 remainder is 0. So 2 by 5 answer is 0.4. Next example 3 by 100. So denominator 100. That means first write the numerator part 3. So denominator 100 is there. So 2 digits before we place decimal point and add a 0. So the answer is 0.03. See another example 12 by 15. By using 15 we are going to divide the number 12. 12 is less than 15. So in the quotient we place 0 point and add a 0 here. Now the number is 120. 15 table 8 times is 120. So 120 minus 120 remainder is 0. So the answer is here 0.8. Let us see another example, that is 33 by 50. Now we are going to divide the number 33 by using the number 50. 33 is less than 50. So in the quotient we shall place 0 point and add a 0 here. Now the number is 330. 50 table 6 times is 300. After subtracting we get remainder 30. Again this 30 is less than 50. We shall add a 0 here. Now the number is 300. 50 table 6 times is 300. So 300 minus 300 remainder is 0. So 33 by 50 answer is 0.66. All these examples are in the form of p by q. So all these are terminating. We observe that the denominators of above rational numbers are in the form of 2 power a into 5 power b, where a and b are whole numbers. Hence, if q is in the form of 2 power a into 5 power b, then p by q is a terminating decimal. So from the above examples, we observe that the given numbers are in the form of p by q and their expansions are terminating decimals. See now question number 7. Write 3 numbers whose decimal expansions are non-terminating and non-recurring. Let us see the solution. We have written 3 examples for this. First one 0.01, 001, 0001, 00001, so on. Next example 0.20, 200, 200, 200, so on. Next example 0.003, 003, 00003, so on. So these are the 3 numbers whose decimal expansions are non-terminating and non-recurring. Today we have seen exercise 1.3, 5, 6, 7 sums. Remaining sums we shall see in the next video. Hope this video is useful to you. Thank you for watching.